Okay, so in this video, I'm going to go over the solutions to the practice midterm, and I'm just going to go through it, and we'll see where we get. On the real midterm, of course, you have to fill out these things, sign here, make sure you read everything, make sure you put your name, but let's just jump to the solutions, and we'll start there. So let's start with the multiple choice. Question 1. Oh, question 0. Bubble in the version number. So make sure you do that on the bubble sheet. You got to bubble in here the version number, version A. Make sure you do that. Okay, let's go to the actual answers now. Question 1. The axis of symmetry of the parabola y equals x squared minus 2x minus 3 is x equals what? To do this one, you need to somehow figure out what the parabola looks like. You could convert the parabola to vertex equation. That would involve some kind of algebra steps, but the way I like to do it is to factor it. So if you do y equals x squared minus 2x minus 3 is the same as x minus 3 times x plus 1. So by factoring it, I can see the roots are 3 and negative 1. So maybe I draw a little thing here. Here's x equals 3, and here is x equals negative 1. And those are the roots. So the parabola goes through those. And actually, because the coefficient in front of x squared is 1, the whole thing opens up. So it looks like this. There's my parabola. So the parabola goes through negative 1, goes through 3, and it opens up. Make sure you do 3 and negative 1. Those are the solutions to x minus 3 equals 0 and x plus 1 equals 0. So that's what the parabola looks like. Where is the axis of symmetry? That's this guy in the middle, and it's going to be halfway between negative 1 and 3. Halfway between negative 1 and 3 is x equals 1. This is x equals 1 in the middle there. So that's the answer to that one. Okay, a lot of different ways to do it. That's how I did it. Question 2, solve 2x equals 3 to the 7. This is one where for sure you don't want to trick yourself by looking at the options. Just do the problem, then match. And to do this one, I guess I'm going to take I want my answer to involve a ln. That's the only thing you got to get from the answers. They all involve ln. So I'm going to take the ln of both sides. So ln of 2 to the x is equal to ln of 3 to the 7. And now by the rules of logs, the exponent here, the x will jump down, right? The x becomes an x ln 2, and the 7 becomes multiplication by 7. So x times ln 2 equals 7 times ln 3. And if you move the ln to the other side, the ln 2, you get 7 ln 3 divided by ln 2. So hopefully that's one of the answers. And look at that. That's option B. Okay, there we go. So using the rules of logs. Let f of x equal b to the x. Which of these options is equal to f of x plus 1? This one was a homework problem. And you basically, all you have to do is f of x plus 1 will be b to the power x plus 1. And you got to simplify this to somehow involve the function f of x. And in this case, b to the x plus 1, by the rules of exponents, is b to the x times b to the power 1. So adding in the exponent is multiplying on the outside. B to the x times b to the 1. That's b to the x is the original function f of x. So this is f of x times b. F of x times b. So the correct answer is A here, A, b times f of x. This one was taken directly from a Math1030 homework. Okay, question 4. Consider the sequence of all 7s, 7, 7, 7, 7. Is it arithmetic or geometric? So arithmetic means the difference between terms is always the same. And the differences here are always 0. So 0, 0, 0. You're always adding 0 to get to the next term. So it definitely is arithmetic. So arithmetic, yes. Geometric means the ratio between terms is constant. To get from 7 to 7, you multiply by 1. So times 1, times 1. You multiply by 1 to get to the next number. So you're also multiplying by 1 every time, and that is a geometric sequence. So this sequence of all 7s, you're adding 0 every time. That means it's arithmetic. You're multiplying by 1 every time. That means it's also geometric. The correct answer is C. Both. Okay. Questions 5 and 6 are two limits that, again, were taken directly from the Math1030 homework. The first one involves n to the power 8 and n to the power 7. Because there's an n to the power 8 and n to the power 7 on the top and the bottom, and we know that the limit as n goes to infinity of n to the power 8 is infinity, and the limit as n goes to infinity of n to the power 7 is also infinity. The top and the bottom are both infinity. This is a type infinity over infinity limit. And so that means we're going to have to do some work to simplify. So just because it's infinity over infinity, anything could happen. You can't conclude that it's none of these or infinity or anything like that or 0. You have to do the work. And in this case, the right thing to do is to divide the top and the bottom by n to the 7. Divide the top and the bottom by n to the 7. Divide top and bottom by n to the 7. And if you do that, you get 2 times n. So the n to the power 8 became just an n after you divide by n to the 7. The 3 becomes a 3 divided by n to the 7. And on the bottom we have 5, so n to the 7 goes away, plus 7 divided by n to the 7. So we have this limit. And now we take the limit as n goes to infinity, and we look at what happens. The 2 times n is going to infinity. That thing is blowing up. That orange term is blowing up. On the other hand, this term with the 3 and the 7, these both go to 0. So this guy goes to infinity, and these two guys go to 0. So this guy goes to 0, this guy goes to 0. So we kind of have an infinity plus 0 divided by 5. So the top is getting really, really big, and then we divide it by something that's close to 5. So what is the whole thing doing? It's just getting really big. The limit is infinity. And again, it's sort of because the power, the exponent in the top here, was an n to the 8. So after we divided it by n to the 7, it still had some leftover oomph to go to infinity, whereas the bottom just went to 5. And the 5 here was always a constant. Okay, very similar idea in question 6. Question 6 is even easier because you don't have to do any dividing. You just have to notice that these two terms, 2 times n to the minus 8 and 5 times n to the minus 7, those both go to 0. So just like we did over there, those both go to 0. So what are you left with? 0 plus 3 divided by 0 plus 7. The laws of limits say as long as all the limits are fine, you can add them and move in. So the top going to 0 and adding 3, the whole thing's going to go to 0 plus 3. So the answer is 3 over 7. 0 plus 3 divided by 0 plus 7. Okay. All right, question 7. Let f be this function, which is piecewise, 7x if x is bigger than 2, and 14 if x equals 2. 14 if x equals 2. And on where is it continuous? So let's see how we would answer this question. First of all, this function is not defined, when x is less than 2, right? Because there's no branch that covers x less than 2. So definitely option A, which is all the numbers, that's definitely wrong because x less than 2 is just not on there. The second thing is that is at least continuous on 2 to infinity because it is equal to the function 7x when x is bigger than 2. So from 2 and bigger, strictly bigger than 2, this branch covers everything bigger than 2, and it's continuous there because it's just the function 7x, and we know 7x is continuous. So the only question to answer between options B and C here, just like in the lecture from class, is it continuous? Is it continuous at x equals 2? And more specifically, is it continuous from the right? Is it continuous from the right at x equals 2? Because if it is continuous from the right at x equals 2, then that would be correct. We'd have a closed bracket at 2 indicating it's continuous from the right at x equals 2. And how do you answer if it's continuous at x equals 2? You got to compare the limit as x goes to 2 plus of f of x versus f of 2. So if those two things are equal, then it's continuous from the right. If they're not equal, it's not continuous. F of 2 is easy because this one is just given to us. This is 14. This is 14. Right? When x equals 2, you just get 14. The limit as x goes to 2 plus is this branch. X is a bit bigger than 2, so this is the limit as x goes to 2 plus of 7x. And to do the limit of 7x, you can just plug in. So we plug in, and we get 7 times 2, and 7 times 2 is 14. So this function, the limit is 14, which came from this pink branch, 7 times 2. And the value of the function is 14 on this blue branch. And because those two things are equal, the function is continuous at x equals 2. And therefore, the correct answer is B. The correct answer is B. So B is the correct answer. Okay. Next up, questions 8, 9, 10, 11 are all variations of this type of 0 over 0 limit. All of them involve some kind of x over some kind of x, and all of them are happening near x equals 0. So we got to figure out what's going on. So just to make sure, this is type 0 over 0. Just because it's type 0 over 0, the answer could be anything. So we got to do more work and figure out what's going to happen. There is no one automatic answer when it's a type 0 over 0. Let's start with the first one, x squared over x. And x squared over x simplifies to just x. So x squared over x is equal to just x, and that's as long as x is not equal to 0. Which it isn't here, because we're just talking about getting close to 0, not exactly 0. So you put a limit sign in front. Let me see, where can I write these? Let's see. Okay, let's scroll down over here. So the limit as x goes to 0 minus of x squared over x is the same as the limit as x goes to 0 minus of just x, because x squared over x is x. And just x on its own is no longer 0 over 0. The 0 over 0 badness went away. Now we can just plug in. Just plug in. And you get 0. So this limit is 0. The first one was 0. And 0 is not on the options. So 0 is none of these. None of these. The answer is 0. Okay, question 9. Question 9 is the limit as x goes to 0 minus of x squared over x squared, which is again a 0 over 0. In this case, x squared over x squared, they completely cancel out. X squared over x squared is the same thing as 1. What's the limit of 1? It's 1. So you can just plug in if you want, or, the limit of 1 is 1. So the answer is 1. Okay, next one up on the list, x over x squared. In this one, the cancellation goes the other way, and you have 1 over x. So before, they were 0 over 0s, and they canceled out with something nice. But now you have a 1 over x, which is quite a nasty function at x equals 0. So as x goes to 0 minus, x is a very, very small negative number. So 1 over x is a very, very big number, but it's negative. So if x is negative, 1 over x is negative. So the whole thing is going to minus infinity. Okay, so hopefully, again, the key step are these simplifications. You got to simplify in all three cases, and you get a sort of different simplification, and it comes out to some particular thing. Okay, last but not least, I think this is the hardest of the three, the absolute value of x over x. And the key is in the hint, which is that we are going x goes to 0 minus, which means we're only looking at negative values of x. And when x is negative, the absolute value function is just negative x. So a lot of absolute value signs, but this means the limit as x goes to 0 minus of absolute value of x over x is equal to the limit as x goes to 0 minus, and absolute value of x on this branch that we're looking at is the same as negative x. Negative x. So it's negative x over x. This is the same idea as we used in this previous problem. Let's see, this one up here, this one over here. In that problem, we had two branches, and we used the branch 7x when x was bigger than 2. In this problem, there's again two branches. We use the branch negative x for the absolute value. And negative x over x is the same as negative 1. Negative 1. So it's the limit of negative 1. What is the limit of negative 1? The answer is negative 1. So that one, this last limit in question 11, the answer is negative 1. Negative 1 is not on the list, so the answer is none of these. Okay, and that is it for the multiple choice. There are the answers. And that was like a super quick explanation of any of the questions. If you want more detail, feel free to ask in Campus Wire or any of the office hours.